A student used a balance to measure the mass of a small cube with sides of length s. The student also measured the mass of a large cube with sides of length 1.5x. Which of the following is the density of the large cube in terms of density of the smaller cube? Now remember, whenever you are asked a question like this in which you have to find the density or any variable for one object in terms of the same variable of another object. So for example, I have two circles, and let's say the diameter of circle B is twice the diameter of circle A. Okay. And I want you to, let's say this is circle A, and if you want to find the area of this circle, area of circle A, and if you want to find area of this circle B, it will be area of circle B. I want you to find AB in terms of area of circle. Okay. So it will be some number here times area of circle A. So whenever you see this kind of problem, you have to follow these steps which I'm about to explain, and you will always be able to answer these questions correctly. If you try to do it in your head, you will always get the wrong answer, or even if you get the right answer, you will not be sure of it that this is the correct option. So it's always better to do it in writing, and you should write your calculations and see that your answer is correct. Okay, we'll start with volume of the small cube. Sorry, density of the smaller cube will just be mass of the small cube divided by volume of the small cube, and density of the large cube will be mass divided by volume of the large cube. In this case, mass of these cubes is the same. You can see it here. Both are 50 grams. So that's why I've not written ms and ml, because they are exactly the same. Now we know that density is related to volume, and we want to find how the volume of large cube is related to volume of the smaller cube. So volume of the large cube is just 1.5x. This is length of one side. And since it's a cube, it's a cubic shape, the volume of cube is just length multiplied by width multiplied by height, which are all the same. So you just cube the length of one side. When you cube it, you will see that the answer is 3.37 times x cube. What about the volume of smaller cube? Volume of the smaller cube is just x cube, right? Length of one side, and you just cube it. It means that this x cube right here can be written as volume of the smaller cube, right? S. So now we have a relation for volume of the large cube in terms of volume of the small cube. Now we can substitute this volume of the large cube here to find density. So we'll have m divided by volume of the large cube, which is 3.37 times volume of the smaller cube. Now again, we will do this substitution, that mass divided by volume of the small cube, as you can see from this equation, it is just density of the small cube. So we will have 1 divided by 3.37, and this mass divided by volume of this small cube. For this, I will just write density of the small cube. You see, now you have an equation. Density of the large cube will be 1 divided by 3.37 times density of the small cube. And if you calculate this number, 1 divided by 3.37, you will see that it's 0.3. So D is the right option. So if you want to practice these, you can try the question that I asked in the beginning of this question. To compare area of two circles, you have to find area of B, circle B, in terms of area of A, given that the diameter of B is twice the diameter of A. So just to practice this whole process, you can try answering this question.